Hey guys, this is 7.1 and 7.2. We are going to start with simplifying, multiplying, and dividing rational expressions. When you hear rational expressions in this class, we mean fractions, okay? So we have all of our polynomials that we've been practicing with all semester, and now we are going to put them in into fractions and continue working with them. The most important skill here is factoring again. So make sure that you're strong with factoring and then identifying what a factor is so that you can factor parts of the rational expression out to make it simpler. So you're going to get a big fraction or a big fraction times another big fraction or a big fraction divided by another big fraction. And when you see those big fractions, the skill I want you to take away from this is how do I simplify this, make it much smaller, okay? All right, so it is called simplifying, multiplying, and dividing rational expressions. When we hear rational expressions or see rational expressions, I want you to think of the form a term or a polynomial over another term or another polynomial. Remember that the division bar means a divide. So P divided by Q might be really big, like 24x squared plus 18x, or it might just be 1, okay? So a polynomial or a term divided by another polynomial or a term. P and Q are polynomials and Q can't be 0, right? Because remember, anything divided by 0 is called undefined. You can't do it. Error. Good. So make sure that Q is not equal to 0. When they ask you about the domain of a rational function, remember that the domain is always your x value and your range is always the y value of your polynomial or of your function. So the domain is any x value you can put into a function and get a real answer. Remember that the bottom can't be 0. Okay, so that's all saying the same thing. P over Q, where Q can't be 0, x over 0 is not defined. Okay, so the domain is your x value. It's any x value except the values of x that makes the denominator equal to 0. Okay, so for example, here we have f of x equals 7x minus 4 divided by 4 plus x. Think about just your denominator, okay? Your denominator is 4 plus x. If that equals 0, then that's not a rational expression. That's not possible, okay? So to find the domain of a rational expression, you take the denominator, I'm not going to write take the denominator, but I'm going to set the denominator. Don't do anything with the numerator, okay? Set the denominator, ER, set the denominator equal to 0. This can't be equal to 0, so set it equal to 0. Solve for x. It's 2 steps. The comma is like the end of step 1. So that's step 2. That's step 1. Step 1, set the denominator equal to 0. Step 2, solve for x. Good? All right, so here we have f of x equals 7x divided by 4 plus x. Take just the denominator and set it equal to 0. So that whole thing equal to 0, solve for x, subtract 4, x is negative 4. What does this mean? Why did I set it equal to 0? And then solve for x, because if I put that x value in right here, that will make the rational function impossible, right? The denominator can't equal 0. So if I say x is negative 4, 4 plus negative 4 equals 0, the denominator is now 0. That cannot be. That cannot be. That is not a rational function. So your domain is all values except x equals -4. So the domain is x such that x cannot be -4. Every number except -4. You can put in -3, you can put in -3.99999, you can put in 1000. You can't put in -4 because then it will equal exactly 0 and it can't equal exactly 0. So that's how you're finding the domain of the rational function. Set the denominator equal to 0, solve for x. The domain is all numbers except the answer. X is anything except -4. Set the denominator equal to 0, solve for x. The domain is all your numbers except what you found for x. Simplifying rational expressions. So that was finding the domain. The domain is set the denominator equal to 0, ignore the numerator, solve the denominator equal to 0 for x, and then the domain is all the numbers except the answer to part 1 and 2. Okay. Now, simplifying just means put it in its simplest form. Just like fractions containing numbers, rational expressions are fully simplified when there are no common factors between the numerator and the denominator. So factor completely, okay? Always factor. If you see something and you're like, oh, 24, 18, and 24, I can divide all of those by 2. X squared, x, and x, I can divide all those by x. Always your first view should be, what can I factor out, okay? And then we divide out, I call it cancel out, right? But you cancel out the factors that are identical. If there is a multiple of x on the top and a multiple of x on the bottom, maybe that one's x times 5 and this one's x times 3, cancel out or divide out factors that are identical. So now it's just, instead of 3x over 5x, it's 3 over 5. Factors are often going to be binomials, and then never divide out part of a binomial that is being added or subtracted. What they mean here is these are not two factors. We don't have the factor of 3x and 42, and I'm going to divide everything by 3, or I'm going to say 3x divided by 3x is 1, and 42 divided by 21 is 2 and over 1, right? Those aren't two factors. This whole thing is the factor, and this whole thing is the factor, okay? A factor, what do they mean when they say only entire factors? A factor is something that is multiple, a multiple. Okay, so we can say this is 3x plus 42 times 1, right? This is y minus 4 times quantity y plus 7. So those are multiples, but y isn't a factor. Y plus 9 is the factor. It's a multiple. If you have a plus sign or a minus sign between them, those are not factors because you're not multiplying. You're adding or you're subtracting. So only a factor is anything you can multiply, okay? Trying to think of, so, oh, here's an easy one. So number 9, 2x plus 2. 2x isn't a factor. 2 isn't a factor because it's a plus sign between them. But you can say that 2x plus 2 is the same as 2 divided by x, or sorry, 2 times x plus 1, right? I can factor out a 2. Now, this is a factor. And this is a factor. Because you're multiplying them. Or you can just say the whole thing can be factored, right? Or is a factor of itself times 1. So factor means multiply. Factor does not, you cannot take something that's being added or subtracted and call it a factor. It's either the whole binomial, or you can factor something out and it's still being multiplied by the binomial. Okay, so I hope that makes sense. Only entire factors rather than something that's being added or subtracted. To show you that rule, we cannot, I kind of went over it, but we'll go over it again. We cannot just look at this and say 3x plus 42 divided by 3x plus 21. Well, 3x divided by 3x and 3x are the same, so those cancel and they're just a 1. And then 42 and 21, I can divide those both by 21 and I can get 42 divided by 21 is 2 and 21 divided by 21 is 1. So it's just 1 plus 2 divided by 1 plus 1. And then that would just be 3 halves. Is 3x plus 42 divided by 3x plus 21 actually 3 halves? It isn't, right? Because we didn't factor it correctly. You do not just go straight down. You can go straight down like the x times 3, x times 5. You can cancel them out when they're being multiplied. Okay? Or when you're canceling out the whole thing, right? 3x plus 42 over 3x plus 42. Oh, sorry, couldn't see that. That, yeah, that is the same, right? Those are exactly the same. And so those cancel, and it's just 1 over 1, which is 1. Here we have y plus 9 times quantity y minus 4 divided by y minus 4 times quantity y plus 7. What is exactly the same? And no, it can't just be here's y, here's y, here's -4, here's -4, here's y, and I have 9 sevenths. That's not going to work. You have to look at the binomials, or sorry, you have to look at the factors. They are binomials, but that's just by chance. So one of your factors is y plus 9. Your other factor is y minus 4. Those are the only things eligible to be factored out or divided out. Here we have y minus 4, and here we have y plus 7. Why? Because they're being multiplied. Okay, that's how you know they are factors, because they're being multiplied. What is common? The y minus 4. Now you have, those are completely canceled out. You have y plus 9 on top, and you have y plus 7 on the bottom. It does not matter that there's a y over a y. Okay, even if it was like 8 and 4, y plus 4, y plus 4, y plus 8, you can't change that to y plus 1 divided by y plus 2. Okay, only factor out things that are being multiplied by each other. So they'll either be alone, like the 3x plus 42, it's just by itself. You can factor that whole thing out if you want, or they'll be in parentheses, and that parentheses means they're being multiplied. Okay, those are the rules. Let's see if we can apply them. So 12x to the third divided by 4x. Just look at 12x to the third. Think, how can I simplify 12x to the third? You're welcome to just say, well, what are the prime factors of 12? 12 is, you can divide it by 2, right? And you can divide 6 by 2. And so the prime factors of 12, oh, sorry, couldn't even see that. The prime factors are 12, oh, sorry, is 6 times 2 times, or sorry, this is a terrible example, 3 times 2 times 2. Right? So that would be the prime factorization, and we do that through factor trees. So 12, just real quick, 12 becomes whatever you want, 2 and 6. 2 is prime, so 6 becomes 2 and 3. The prime factors of 12 are 2, 2, and 3. And then the prime factor of x to the third is just 3 x's. And then here 4 is 2 times 2, right? And x. So you're welcome to do it that way. And then divide out factors that are identical. The x's were identical to the top and the bottom, and they're being multiplied by something. We can cancel them out or divide them out. Here's a 2. Here's a 2. There's no 3 common to the top and the bottom. Okay, sorry. There's no 3 to the common to the top and the bottom, so we're just going to leave the 3 on the top, and then we have an x and an x. And then we are out of more x's. We canceled out all the bottom x's, which was only 1, and 1 on the top. So now we are left with 3x squared on the top. We canceled out the entire 4, and the x. You don't leave it as a 0, right? You just leave it as a 1 for a placeholder. So that is just 3x squared, because 3x squared divided by 1 is just 3x squared. Good. So 12x to the third divided by 4x is 3x squared. You could have also just said, well, what is 4? So I have 4 on the bottom. Can I divide 12 by 4? That's always a good trick. 12 divided by 4 is 3. So that'll give me 3 on the top. 3 times 4. X to the third. 4x, right? And then we didn't have to do the prime factorization and cancel out 2 2's. We can just cancel out the 4 and the x, and we still get 3x squared. Good. All right, once you have 2 terms, you want to look at both of those terms, and you have to, if you were able to factor the numerator and the denominator, sorry, real zoomed in today. If you are able to factor the numerator and the denominator before you start dividing out the factors, do it, okay? Factor first. So just don't even look at the bottom, just 24x squared plus 18x. What can I factor out of 24x squared plus 18x? Well, I know that their x squared and x have an x in common, right? And then what's the biggest factor that is common to both 24 and 18, okay? So the factors of 24 are 1 and 24, 2 and 12, 3 and 8, I think, 4 and 6. I feel like I'm making this up now. Those are the factors of 24. And the factors of 18 are 1 and 18, 2 and 9, 3 and 6. Why do I not know? 18 divided by 6 is 3. 24 divided by 8 is 3. Just good to make sure. All right, so those are my factors. There are some common ones, right? So common to 24 and 18, we have 1, which is not helpful, but I accidentally touched my highlighter to it. We have the number 2. We have the number 3. That's it. We have the number 6. All right, those are the common factors. And then the greatest common factor is just the biggest number between 2, 3, and 6. So that is 6. So the greatest common factor of 24 and 18 is 6. Good. We're going to factor out a 6x from 24x squared plus 18x. 24 divided by 6 we know is 4. X squared divided by x is x. Positive 18, so we know it's going to be a plus. 18 divided by 6. 18 divided by 6 we decided was 3. X divided by x gets rid of the x. So we have simplified 24x squared plus 18x to 6x times 4x plus 3. Good. Now, on the bottom, all we have is a 24x. I want to factor out, and if we look at this, what we have, this isn't 6x, it's 6 times x times 4x plus 3. It's very important to keep those parentheses, but this is just 6 times x, so it's not really... if this was a 5x, you could still cancel out the x's that were common without canceling out the 6, okay? So remember, a number next to a variable means you're multiplying them, and a factor is anything you multiply by something else. So the 6 is separate from the x, which is separate from the 4x plus 3, but that is one factor. That's why the parentheses, hence the parentheses, okay? So now that I know I have 6 times x times 4x plus 3, well, 24x, I cannot get 4x plus 3 as a factor of 24x. So I know I can get x, right? X divided by x, those will cancel. And then 6, can I take 24 and can I divide it by 6? 24 divided by 6 is 4. So 24 becomes 6 times 4 times x. Does that make sense? Because I want to factor out this 6. So I did the hard one first. I saw that there was a 6 and an x and a binomial that I won't be able to factor out. And so I wanted to see, because this factor is 6, can I divide 24 by 6? And I can. 24 divided by 6 is 4. So I'm going to rewrite it because I kind of kept writing over myself. 6 times x times the quantity 4x plus 3 divided by 6 times 4 times x. And now we cancel. Okay. There's a 6. We divide out. We divide out the 6's. 6 divided by 6 is 1. X divided by x is 1. And we are left with 4x plus 3 over 4. You cannot take it any further because this is a binomial. If this is a binomial and this is a monomial, you'll never be able to factor unless you want to divide both the 4 and the 3 by 4, which interestingly, then you would just be 4 divided by 4x plus 3 divided by 4x. Sorry, ran out of space, which is x plus 3/4 x. So you could call it that. That's the same. Because 4 divided by 4 is just 1. 1x is x. 3 divided by 4. Oh, there's no x. Good thing I was. The part I drew off the page didn't even exist in the first place. So to state that again, 4x plus 3 divided by 4 could also be called x plus 3/4 because you can break it apart, but you can't really continue simplifying the whole thing. You can break it apart though. Good. Next we have negative 2x minus 2y over the positive x plus y. When you have a negative number, it's a binomial, right? Put the leading term first. So if you had an x squared, make sure your x squared is first. Here we don't have an x squared. X and y are both to the power of 1, so there is no leading term. And then if your leading term is negative, divide out a -1 or multiply by a -1, whichever way it's easier for you to think about it. So we have negative 2x minus 2y. Ooh, let's not do that. Let's not do that. Let's just say that the common factor is -2. And I'll save that other explanation for the next problem. So negative 2x minus 2y, we're trying to factor it completely. The only common factor to negative 2x and negative 2y is -2. So that becomes -2 times the quantity. Negative 2x divided by -2 is a positive x. Negative 2y divided by -2 is a positive y. So here I have -2 times x plus y divided by, and then x plus y, perfect, right? Just like we saw up here, if they are exactly the same at the top and the bottom, you can cancel them. It's just 1 divided by 1, which is 1. Or here, y minus 4 times something else. On the bottom, y minus 4 times something else, you can cancel them. So here we have -2 times x plus y divided by x plus y. Cancel them out. Your final answer is just -2. Good? All right. 7x minus 49 divided by 3x minus 21. My leading term is positive, so I'm going to divide it by a positive, not a negative. We don't care if the second term is negative. We sometimes care if the first term is negative. If you have to pick, keep the second term negative, not the first. 7 and -49, you can divide them both by 7 because 7 times 7 is 49. There's no variable common to both of them. So 7x minus 49 simplifies to 7 times x minus 49 divided by 7 is 7. Good? Now, we have, that becomes 7 times x minus 7, right? Here I have a 3x minus 21. One of my factors is 7. I don't think 3x is going to go into 7, right? Negative 21 does go into 7, but it would need both of them to go into 7, right? So my only other possibility is the x minus 7. So can I pull an x minus 7 out of 3x minus 21? Well, that would mean that I'm dividing the 3x minus 21 by what? What's the only thing I can pull out of 3x and negative 21? It's a 3. Good. 3x, oh, sorry. Ran out of space, of course. 3x divided by 3 is x. Negative 21 divided by 3 is a negative 7. So that one is 3 times x minus 7. So the whole thing is 7 times x minus 7 divided by 3 times x minus 7. We can't divide out the 3 and the 7. Those are not common, right? And we can't divide 7 any further. They're both prime, but the binomial x minus 7 is common to both. So the final answer of this is, in fact, 7/3. And we are done. Good. All right. 3x minus 18 divided by x squared minus 36. 3x minus 18. What is a factor common to 3x and 18? It's going to be the number 3, right? If I pull 3 out of 3x, I get x. If I take negative 18 and divide it by 3, I get negative 6. Now, this bottom one looks difficult, right? This looks very difficult. I have an x squared, but my 36 doesn't have an x, and I have no number in front of x squared. So how do I factor anything about this? Here, remember, I know it was difficult to do the factoring. We're glad like the factoring tricks are over, but remember that I want a darker color, so we remember it. A squared minus b squared equals the quantity a plus b times the quantity a minus b. X squared is a perfect square and 36 is a perfect square, so that means x squared minus 36 is x plus 6 times x minus 6. So instead of x squared minus 36, the factored form of that is x minus 6, x plus 6. And then we just cancel. The common factors are x minus 6. So we end up with, final answer, 3 over x plus 6. The parentheses don't matter because there's nothing to multiply x plus 6 by. So you can keep the parentheses, you can lose the parentheses, it doesn't matter. And that was our introduction to the more complex factoring. So now we might be encountering further examples of complex factoring. You want to always, though, do the easy factoring before the difficult factoring, okay? What I mean by that is when you have 10x squared plus 18x plus 8, divide it all by 2 first before you try to factor it, okay? Divide out the 2 so that it's easier to do the trinomial factoring. 2x plus 2, well, the only thing I can divide out of 2x and 2 is 2. So I'm going to simplify that to 2 times the quantity x plus 1, right? 2x divided by 2 is x, and then 2 divided by 2 is 1. So 2x plus 2 is equal to 2 times the quantity x plus 1. Now, 10x squared plus 18x plus 8. It should always be in descending order, right? I can divide all of these by 2. I guess I can't, if I wrote it as one big equal sign. I can't put 2 here, 2 here, 2 here, because that's confusing. So I'm dividing them all by 2. 10x squared divided by 2 is, 10 divided by 2 is 5. X squared. Positive 18x divided by 2 is a positive 9x. And then 8 divided by 2 is 4. How did I decide that 2 was the biggest factor? Because 10 is, right? 10 is 1 and 10 and 2 and 5. 18 is 1 and 18, 2 and 9, 3 and 6. 8 is 1 and 8, 2 and 4. The only common factor is the 2. So I factored out the 2. That's how I decided. Good. All right. So, and maybe we don't even have to have 5x squared plus 9x plus 4 into a factored form, because we're just factoring out what we can. No, we should, because there might be an x plus 1. Okay. So we know we can factor out the 2, and then the 5x squared plus 9x plus 4, you want to go back to the factoring that we were doing in the last unit, which is, it needs to multiply to equal a times c, and it needs to add to equal b. When it adds together, when the two factors add together, they should equal the 9, and when they multiply them, they should equal the 5 times 4, which is 20. So it needs to multiply to equal 20, and it needs to add to equal 9. It'll work if you don't take out the 2 first, but you'll just get way bigger numbers over here, and that's like annoying. So the multiples of 20, and we add them to the positive, and we multiply them to the positive. So we're only going to talk about the positive factors of 20, which are 1 and 20, 2 and 10, 3, no, 4 and 5. That's all. Do any of those add up to 9? 4 and 5 add up to 9. Because of this 5 here, we can't just say it's x plus 4 times x plus 5. That is not true, because x times x won't give us 5x squared, right? Instead, we keep the 5x squared. We keep the 4. And 9x becomes plus 5x plus 4x. Good? All right. Now, factoring by grouping, because there's no common factors. 5x squared plus 5x, I can take out a 5x. 5x squared divided by 5x is x. 5x divided by 5x is 1. Here we have 4x plus 4. Divide them both by 4. Sorry, I didn't really show that I was dividing them both by 5x here. Divide those both by 4, and we get plus 4. 4x divided by 4 is x. 4 divided by 4 is 1. And the factored form of 5x squared plus 9x plus 4 is x plus 1 times 5x plus 4. Good? So remember that original 2. And then the 5x squared plus 9x plus 4 becomes x plus 1 times 5x plus 4. Now, what can we factor out? We can factor out the 2, and we can factor out the x plus 1, and we are just left with 5x plus 4. It's on the bottom, so we put a 1 on the top. That's the answer, number 9. Good? All right. Here we have 3x squared plus 9x cubed. How? Three x squared plus 9x cubed. Again, always do the easiest way first, right? Which is dividing out a binomial. 3x squared and 9, you can divide them both by 3. X squared and x cubed, you can divide them both by x squared. So we're going to divide both of these by 3x squared. Three x squared divided by 3x squared is 1. And then 9x cubed divided by 3x squared. 9 divided by 3 is 3. X cubed divided by x squared is x. Good. So 3x squared plus 9x cubed is 3x squared times 1 plus 3x. And it would probably actually be best to call it three x plus 1, just to put it in descending order, put the variable in front. It's kind of out of room, so I won't, but that is better written as 3x squared times 3x plus 1 for the top term. Seven x plus 21 squared. I can divide both of those by 7x, right? 7x divided by 7, oh, sorry, 7x. 7x divided by 7x is 1. 21 divided by 7 is 3. X squared divided by x is x. So we have that same 1 plus 3x. I'm going to switch it to 3x plus 1. So sometimes on the bottom, it'll look like 1 plus 3x, and then maybe on the top, it'll look like 3x plus 1. That's the same binomial, okay? They just switch the terms, and that's perfectly fine. It doesn't change the value to switch the order. So 3x squared divided by 3x, or sorry, times 3x plus 1 divided by 7x times 3x plus 1. That simplifies to 3x squared over 7x. Wait a second. We can even cancel out one of the x's, right? Because that's actually 3 times x, and that's 7 times x. So it's actually 3x over 7. Final answer. Good? Okay. Number 11, put your polynomials in descending order, and if the leading coefficient is negative, factor out the greatest common factor of -1. So this is what I meant back on number 6 when I was like, oh, let's factor out a -1, but we factored out a -2 instead, and it was way easier. Now we can factor out a -1, okay? So 5x minus 15 is, divide them both by 5, and you get 5 times x minus 3. 6, oh, sorry, so it's done. 5x minus 3. Here we have 6 minus 2x. And it says, put them in descending order. 6 minus 2x becomes negative 2x plus 6. Remember, I said you can switch the order, but you want to keep, if it's a minus 2x, you want to keep it as a negative 2x, okay? So you can switch the order, but don't switch make sure you keep the terms positive or negative, okay? Now, if the leading coefficient is negative, factor out a negative. It doesn't have to be a -1, but factor out a negative. If nothing factors, then it becomes a -1. It's the same as when we were doing factoring by grouping. If it was a minus here, we would make the number we divided out a minus, right? So because the leading term is a negative 2x plus 6, we're going to factor out a negative. 2 and 6, you can divide them both by 2, so we're going to factor out a -2, just like we did with number 6. Meaning this guy, we factored out a -2. So 6 minus 2x becomes -2x plus 6, which becomes -2 times -2x divided by -2 is a positive x. 6 divided by -2 is a -3. -2 times x minus 3. What do we have in common? The x minus 3. So it's just 5 divided by -2, which is also -5 divided by 2, which is -5/2. Those are all the same. Doesn't matter where you put your negative, don't put it both places. In fact, if you put it both places, then it becomes positive, right? So for example, we have -6 divided by 3 is a -2. 6 divided by -3 is -2. -6 divided by 3 is -2. Oh, sorry, you couldn't see any of that. Here it is. Good. Negative 6 divided by 3 is a negative. 6 divided by negative 3 is a negative. Negative quantity 6 divided by 3 is a negative, but negative 6 divided by negative 3 is positive. Okay, so you can put the negative, if you have one negative sign, you can put it at the bottom, you can put it at the top, you can put it out in front. If you put it both places, it becomes positive. Okay, so the rule is negative divided by negative becomes a positive, and the negative sign could be here. That's exactly equal to the negative sign being here, which is exactly equal to the negative sign being here. So here it was a negative 2 on the bottom, so we just put it out in front, negative 5/2. When we're looking at binomials, what that means is negative quantity 6 minus x minus 6 divided by quantity 6x plus 6 is the same as putting a negative on top, but of the entire binomial, right? Because it wouldn't just be negative x minus 6. That is not equivalent. Negative x minus 6 means that x becomes negative and the 6 becomes positive because we carried the negative sign. Negative x, positive 6. So it's not that, it is that. That's why you have to put the parentheses. Good. Or you can put it down on the bottom, negative x plus 6. It's not just going to be negative x plus 6. It's going to be negative x minus 6 because we're distributing that negative sign. Very important, okay? Simplify the rational expression 5x minus 15 over 18 minus 6x. So 5x minus 15 is going to become, we can divide them both by 5. 5 times x minus 3. 18 divided by 6x. I guess I could write it up here. We're done with the top. 5 times x minus 3. 18 minus 6x, I'm going to switch the order. Negative 6x plus 18, because I want it in descending order, so the constant should be at the end. What can I divide negative 6 and 18 by? By 6, but my leading term is negative, so I'm going to divide by a negative. Negative 6 times negative 6x divided by negative 6 is a positive x. 18 divided by negative 6 is a minus 3. Negative 6, x minus 3. Those cancel, and it's 5/6. That negative makes it a negative 5/6. Good. All right, 15 looks confusing, but we can do it, don't worry. 6 minus x. Put it in descending order. Negative x plus 6. It's not minus 6 because that 6 is a positive. X minus 6 is just x minus 6. Can I divide anything else? Possibly, okay? Negative x plus 6. I don't want my leading term negative because this leading term isn't negative and they're kind of similar, so I might be able to factor it out. What can I factor out of a negative? Factor out a negative 1 from both parts. And instead of negative x plus 6, I have negative 1 times positive x minus 6. So negative divided by negative becomes a positive, but the positive divided by negative becomes a negative. So that's now negative 1 times x minus 6 over x minus 6. They were the same. They cancel out, so it's just negative 1. 6 minus x divided by x minus 6 is negative 1. (16) is 2x minus 6. It's in descending order. Let's divide them both by 2, and we get 2 times x minus 3. (3 minus x). Let's put it in descending order. So we have negative x plus 3. That looks kind of like that one. So let's divide out a -1. Negative divided by negative. Oh, sorry. So it's a -1 times. Negative divided by negative is a positive. Positive divided by negative is negative. So we have 2 times x minus 3 divided by -1 times x minus 3. Becomes 2 divided by -1, which is -2 over 1, which is -2 for number 16. All right, number 17. X squared minus xy plus 3x minus 3y. How are we going to factor this? There's no common factor, so we'll factor by grouping, right? X squared minus xy. I can factor out an x. And that becomes x times x squared divided by x is x. Negative xy divided by x is a negative y. Over here, we have a positive 3x minus 3y. I'm going to divide out a 3. I should divide out a positive 3 because that's a positive leading term. 3x divided by 3 is just x. Negative 3y divided by 3 is a negative y. So when I factor by grouping x squared minus xy plus 3x minus 3y, it becomes x minus y times x plus 3. On top. Good. And on the bottom, I think it's just x plus 3, right? We can't really factor x plus 3. You can put parentheses around it just to times 1, right? Just to show that it's a factor. To remind yourself that it's a factor. So we have x minus y over 1, which is just x minus y for 17. Good. All right, you're doing great. We just have 1, 2, 3, 4, 5, 6, 7 more. And then we'll divide. All right. When multiplying fractions, so now we're going to move on to multiplying. That was just simplifying. Now we're going to multiply them, and then on the last page, we're going to divide them. So when multiplying fractions, we multiply first and simplify second. We should not do that, okay? Do not do that. Simplify. So all multiplication rational expressions are just longer simplifying problems. So we want to simplify first before we multiply, just because it might be easier. Okay? We don't need to, for example, okay? Divide is not what we're doing, sorry. So the step 1 and step 2, like we're skipping step 1, that's not for multiplication, that's for division. So we're just focusing on simplifying for multiplying, okay? 4x squared times 15 divided by 5 times x cubed. So we multiply first and then simplify. Do not do that, okay? What you're doing is we're just saying this multiplication sign is the very same multiplication sign that we have between this -2 and this binomial. The same multiplication sign that's between the 6 and the x and the 4x plus 3. So don't do anything. Don't say, oh, what is 4 times 15? Put it in your calculator. No, just say it's 4 times 15 times x squared. You're just spreading it out, okay? Because that's going to make it easier to simplify. If you get a really big number when you multiply 4 times 15, then you're going to have to divide it all by 5 anyway, right? Because there's a 5 on the bottom. So 4x squared times 15 is just 4 times 15 times x squared. 5 times x cubed is just 5 times x cubed, which you could even write out as x times x times x. Okay, we're trying to keep it simple. We're trying to keep numbers small. 4 and 5? No. 15 and 5? Yes, because 15 is actually, right? 15 is actually 5 times 3, and x squared is x times x. So the more you spread it out and the less multiplying together you do, the better, because the more you'll be able to see what you can factor out. So once we do this, we can see that we divide out the 5 and we divide out 2 of the x's, and we are left with 4 times 3, no x's, over x. 4 times 3 is 12. 12 over x. If we had done 4 times 15 divided by 5, we would have also got that. Oh, sorry. 4 times 15 is 60, divided by 5 is 12. So we would have gotten that 12 anyway, but you don't need to do it, okay? Next, we have 8 times x on top. And on the bottom, we have 3 times, be very careful, that is an addition sign, so it all goes in parentheses. That's one factor. Good? 8 and 3, can't divide those. Can't divide out this binomial because those are being multiplied. So that's just what it is. 8x divided by 3 times x plus 8. You could even say it's 8x divided by 3x plus 24. But that doesn't change anything, and they usually want it in its most factored form. So all I did there was distribute the 3. Does not mean I can factor anything out, okay? All right, remember, if you have a binomial, it's now in parentheses because we're multiplying it by another division problem. 5y times 14y plus 7 divided by 5 times 10y plus 5, right? And that 5y is actually 5 times y, right? 14y plus 7. 14y plus 7. I see a factor, right? I can divide them both by 7, and 14y plus 7 becomes 7 times 2y plus 1. So I'm going to replace 14y plus 7 with 2y plus 1. So it's 5 times y times 7 times 2y plus 1. Really living on the edge at the end of these papers. 10y plus 5, I see a factor in there too, right? 10y plus 5, I can divide them both by 5. 10y divided by, 5. 10y divided by 5 is 2y. 5 divided by 5 is 1. So that's still 5 here times 5 times 2y plus 1. So we're not multiplying, we're dividing. Even though it's saying to multiply, that doesn't mean take 5 and multiply it by 14. It's just spread it out as much as you can, simplify that if you can, right? And then see what you can cancel out. So the reality is that 5y times 14y plus 7 becomes 5 times y times the 7 we factored out. And then that simplifies to 2 times 2y plus 1. Down on the bottom, 5 times 10y plus 5 becomes 5 times the 5 we factored out times the quantity 2y plus 1. 5 times 7 times y times 2y plus 1 divided by 5 times 5 times 2y plus 1 is 7y over 5. And the only reason I even left this as 5 is because it's a prime number. 5 and 7 are primes. You can't divide them by anything except 1 in themselves, right? So 21 looks difficult, but it just factors out to 7y divided by 5. And those are all skills that are just simplifying, not anything too big, not making the number bigger by saying 5 times 14, 5 times 7, 5 times 10, 5 times 5. That just gets really big. You're more likely to make mistakes. I don't like big numbers. They overwhelm me faster than smaller numbers. All right, so here we have 3x minus 3. So even before, what I could have done before I lined all these up was I could have factored out the 14y plus 7, right? So here we have a 3x minus 3. And if we think about that, 3x minus 3, I can divide out of 3. 3x minus 3 becomes 3 times x minus 1. So I'm replacing 3x minus 3 with 3x times x minus 1. Same with the 8. 8x minus 8. What's the common factor? It's 8. So it's 8 times x minus 1. Now I'm going to stack them all up, all right? So it's 9 times x squared is x times x, just to be clear, right? Times that 3 times x minus 1. Because if that's a binomial, we're probably going to have a binomial factor in the end, okay? And then on the bottom, we have x times 8 times x minus 1. Good. Now we have 9 times 3 times x over 8. 9 is also 3 times 3, right? And 8 is also 2 times 2 times 2. But none of that factors, right? So we could also call it 3 times 3 times 3 times x over 2 times 2 times 2 times x, just to make sure we don't have any common factors, because those are the prime factorizations. But, oh, sorry, there's no x down here. But you don't need to. You can trust yourself that that's an even number, and that is the number 27. So it's just 27x divided by 8. And you can even say, well, let's just make sure. Can I divide 27 by 8? I cannot. Well, I can, but it doesn't give me a whole number. I can't factor it, right? All right, here we have 35x plus 35 times 50x minus 25 divided by 10x minus 5 times 7x squared minus 7. So again, let's factor them first. 35x plus 35 becomes 35 times x plus 1, right? And then on the bottom, below that, we have 10x minus 5. I'm going to divide them both by 5. And I get 5 times 2x minus 1. So that's what that became. 35x plus 35 became 35 times x plus 1. 10x minus 5 became 5 times 2x minus 1. Other side, we have 50x minus 25. I can divide both of those by 25. And that becomes 25 times 2x minus 1. And then on the bottom, we have 7x squared minus 7. Divide them both by 7, right? And we get x squared minus 1. This one's not done. X squared minus 1 follows the rule for a squared minus b squared equals a plus b times a minus b. So believe it or not, x squared minus 1 simplifies to 7 times x plus 1 times x minus 1, because it follows the a squared minus b squared rule. All right, so let's put all of those together. So now we have 35 times x plus 1 times, right? So I'm just going to go straight across, times 25 times 2x minus 1. Good. And then on the bottom, we said that 10x minus 5 becomes 5 times 2x minus 1 times 7x squared minus 7 becomes 7 times, and then x squared minus 1 becomes x plus 1 times x minus 1. Now look at the numerator and the denominator, see if there's anything you can divide out, okay? I can divide out the x plus 1, and I can divide out the 2x minus 1, right? I think, right? I think that 35 divided by 5 is going to give me 7. Actually, let's just, there's several ways to do that one. So what we have now is 35. So that simplifies to 35 times 25 over 5 times 7 times x minus 1. Right? These are in prime factorization. These are not. So 35, the prime factors of 35 are 5 times 7. And then the prime factor of 25 is 5 times 5. Or you can just say, well, 35 divided by 7, 25 divided by 5. You can do it however you want, okay? 5 times 7 times x minus 1. You just want to make sure that you can't divide out a 5 or a 7, or you can just multiply 5 and 7 together, right? 5 times 7 is 35. 35 divided by 35 cancels, and I just have 25 over x minus 1. So however you want to do it, this is the factoring form, prime factorization form. 5s cancel, the 7s cancel, and you're just left with the 5 times 5. So that's 25 over x minus 1. You don't need the parentheses, but you can have them if you want. Good. All right, so that's 23. 24 is our last multiplication problem, and then we're going to go on to division. A squared minus x squared times a. Remember, a squared minus b squared equals a plus b times the quantity a minus b. That's what we're doing, okay? So a squared minus x squared is just going to be a plus x times a minus x, and we're still multiplying it by a. So that's the top. The bottom, a plus x, there's nothing to factor out, right? A squared minus ax, let's look at that. What factor is common to both of them? A. So that's going to become a minus x, right? I factored out the a, and I got a times a minus x. One. If everything cancels on the top, you leave a 1 placeholder. Everything cancels on the bottom, you leave a 1. 1 divided by 1 is 1. It's not going to be 0, right? It's going to be 1. $25. All right, we are moving on to division. Do not worry. Remember the rule for dividing anything. It's just like multiplication, but first you KFC it. You keep the first term, flip the second term, and change from division to multiplication. We've got one more multiplication. Oh, these take forever. All right. You might encounter one, so I should teach it to you, right? Tis my job. All right, so it's x squared minus 9x plus 20. We need two numbers that multiply to equal 20 and that add to equal 9 for this first one. Right? So what are the factors of 20? 20 is 20 and 1, 10 and 2. Oh, it's a negative 9. Sorry. So it would be negative 20, negative 1, negative 10, negative 2 because they two negatives multiply to a positive, but they add to a negative. Negative 3, no, negative 4, yeah, negative 5 times negative 4. Negative 5 plus negative 4 gives us negative 9. So x squared minus 9x plus 20 becomes x minus 5 times x minus 4. Good? All right. The next one is x squared minus 17x plus 72. Again, we're just going to factor it. It needs to multiply to equal 72, and it needs to add to equal negative 17. So again, we're looking for negative factors of 72. 72 is negative 72 and negative 1. Negative 36 and negative 2. Negative 24 and negative 3. Negative 18 and negative 4. It wouldn't be 5, right? Negative 12 and negative 6. Make sure none of them are adding up to 17, which they're not. We got up to 6 divided by 7. Doesn't work. 72, well, obviously, because 70. 72 divided by 8 is 9. Negative 9 and negative 8. And those do add up to negative 17. So x squared minus 17x plus 72 becomes x minus 9, x minus 8. Good. All right, next term is x squared minus 10x plus 16. Good. We want two numbers that multiply to equal a positive 16, but add to equal a negative 10. Oh, good. The 72 is the biggest number. All right. Multiply to equal 16 is going to be negative 16, negative 1, negative 8, negative 2. 3. 16 divided by 3, I don't think so. 16 divided by 4 is negative 4 and 4. Any of those add to 10? Negative 8 and negative 2. So x squared minus 10x plus 16 becomes x minus 4. Or sorry, x minus 8. I was like, why would it be a perfect one? X minus 2, x minus 8. Good. And then we have x squared plus minus 6x plus 5. So we need to multiply to equal 5, add to equal 6, negative 6. So it's going to be negative 5, negative 1, right? X minus 5, x minus 1. I know, I'm assuming that you are very familiar with factoring because that was a lot of work and didn't want to do it. So factoring just means you multiply. So I went a little fast. So all of those are factors now, obviously. Try to keep it corresponding. So those two top terms were being multiplied by each other. So now it's 4 terms being multiplied by each other. At the bottom, we had 2 terms being multiplied by each other. Now we have 4 terms being multiplied by each other, right? So now we just look and we see if there's any that we can cancel. Okay. So it's x minus 5 times x minus 4 times x minus 9 times x minus 8. Doesn't matter what order you put them in. On the bottom, x minus 2 times x minus 8 times x minus 5 times x minus 1. There's not a ton, but there are a few. X minus 5 and x minus 8. Leave it in factored form. Okay, so now you have x minus 4 times x minus 9. On the bottom, you have x minus 2 times x minus 1. Good. They want you to leave it in factored form. If they don't want you to leave it in factored form, you just say, well, x times x is x squared minus 9x minus 4x plus 36, right? X squared minus 2x minus x plus 3. You could call it that, but then those would become and that one would become x squared minus 3x plus 3. But they won't ask you that, but just to show you that you can unfactor it. All right, find the quotient and simplify. So remember, KFC, keep the first term, flip the second term, change the sign. So we're changing the sign from division to multiplication. And in order to do that, we had to flip. Now the 72x to the fourth is on top and the 56x is on the bottom because multiplying is easier than dividing. That's why we did it. 7x to the 10th, 9x to the 5th. So we keep the first term, flip the second term, change the sign. KFC. Keep, flip, change. Keep, flip, change. Good. All right. You're welcome to simplify like this. You can say, well, 7x to the 10th divided by 9x to the 5th is seven x to the 5th over 9, right? 5 of those x's would cancel out, and so that would be simplified as that. 72 divided by 56 . 72 is, I don't know, what's the factor of 72? 72 is, I guess, divided by, should we divide by 8 and 9? I didn't want to start with 2 because it takes a while. 9 becomes 3 times 3. 8 becomes 2 times 4. 4 becomes 2 times 2. So the factored form of 72, the prime factorization of 72 is 2 times 2 times 2 times 3 times 3. Right? And then 56 . 56 is 8 times 7. 7 is prime. 8 is 4 times 2, as we know. And then 4 is 2 times 2. So the prime factorization of 56 is 7 times 2 times 2 times 2. And then we had 1x. You're also welcome to, well, 8 and 8 are common. So you're also welcome to call 72 divided by 56 8 times 9 divided by 8 times 7, which is 9 over 7. You don't have to do the prime version where you're crossing out more stuff, but you can. So you're welcome to simplify both of these before you multiply them, just so you're multiplying smaller stuff. You don't have to, whatever way you like. So 72 divided by 56 is in fact 9/14. How many x's are left? 3 out of the 4 x's, right? So I guess just keep using this space. 7x to the 10th divided by 9x to the 5th becomes 7x to the 5th over 9. And then 72 divided by 56 is 9/14. 2 times 2 times, sorry, I wrote an extra 2, not 14ths. 9/14, 9/7. I promote the prime factorization way, but then I make a bunch of mistakes. And then the x's are up with the 9s. So if that made sense to you, if that looked easier to you than combining them all, you're welcome to do that because that's a lot of x's. Good. So it's 7 times x to the 5th times 9 times x to the 3rd over 9 times 7. But that's nice because now we have a 9 and a 9 and a 7 and a 7, and we just cancel them. So I know I made it look complicated, and I apologize, but it did make it easier in the end. So that's just x to the 5th times x to the 3rd, which is x to the 8th. It's over 1, so it's just itself. Good. So go ahead and simplify it beforehand or put it all together like we had been doing previously. Whatever you would like. 27 asks for the quantity x plus 8 times the quantity x plus 1 over 3x. Nothing to simplify here. Divided by 4x plus 32 by 12x to the 7th. 4x and 32. Well, can I take 32? I can at least divide it by 2, right? Can I take 32 and divide it by 4? Yes, I can. It's 8. So I'm going to call this 4 times x plus 8. And then if I've factored out a 4 here, that 12 I can turn into 4 times 3, right? Why would I do that? So that I can cancel out the 4s. I'm still just factoring as much as possible so that I can factor out, get rid of things that are common to the top and the bottom, even before I start dividing or multiplying. Okay, so instead of 4x plus 32 divided by 12x to the 7th, I'm calling it 4 times the quantity x plus 8. And then I'm calling 12 4 times 3 so that I can simplify it. So now it's nothing changed over here, x plus 8 times x plus 1 divided by 3x. Here we have x plus 8 over 3x to the 7th. That looks easier, right? That's easier than that. All right, now keep, flip, change. Now we're gonna start switching from division to multiplication. Everything over here is still the same. X plus 8 times x plus 1 divided by 3x. Change to multiplication, flip. The 3x to the 7th was on the bottom, now it's on the top. This is x plus 8. Now we just multiply straight across. 3 times x to the 7, or 7x's, times x plus 8 times x plus 1. All of those becomes that. On the bottom, we have 3 times x plus 8. Those cancel, x to the 7th and x, right? Imagine it, it's 7x's up here and 1x down here. They cancel and it becomes x to the 6th. So now I have x to the 6th times x plus 1. For 27. Or you could say it's x to the 7th plus x to the 6th if you multiplied it out. But they want you to leave it in factored form. All right. 28. Guys, only 2 more. 28 is y minus 2 squared divided by 7 divided by 7y minus 14. Again, let's simplify before anything else. Okay. Y minus 2 squared before we start dividing, simplify this. Y minus 2 squared means y minus 2 times y minus 2. And I guess that's all the simplifying you can do. Divided by, how do I simplify this? 7y minus 14. Divide both by 7. 7y minus 2. Good. I see there's a 7 that I've factored out. So 49 is 7 times 7. If you have a factor here, try dividing the other part of the fraction by the factor you found. 49 divided by 7 is 7. So 49 is written as 7 times 7. It means I can cancel those. Don't start canceling across yet, okay? Because it's still division. Rewrite that as y minus 2 times y minus 2 over 7. Keep, flip, change. So multiplying that. Those are canceled. On the bottom, all I have is 7. It now goes on the top. And the top, all I have is y minus 2. Goes on the bottom. So if I was to write it all together, it would be 7 times y minus 2 times y minus 2 over 7 times y minus 2. Final answer, y minus 2 for 28. All right, guys, last one, 29. X plus 7 divided by 6 minus x. Now, you do not have to simplify first and then change it. We can change it right now. Keep, flip, change. So I'll flip it. There was an x squared minus 13x plus 42 on the bottom. I'll put that on the top. X squared minus 4x minus 21 is on the top. I'll put it on the bottom. X squared minus 4x minus 21. Now we're seeing if we can factor x squared minus 13x plus 42, and hopefully it has a 6 minus x involved, which I guess I should have simplified. X plus 7. 6 minus x is negative x plus 6. We don't really like those. Factor out a negative 1. Negative x divided by negative 1 is a positive x. Positive 6 divided by negative 1 is a negative 6. Didn't really catch that. So instead of x plus 7 divided by 6 minus x, we're going to call it x plus 7 divided by negative 1 times the quantity x minus 6, so that our leading term is positive, times x squared minus 13x plus 42 over x squared minus 4x minus 21. Now, when I factor this, hopefully one of the factors is x minus 6, now that x minus 6 looks normal. All right, here, a is 1, b is negative 13, c is 42, so we want two terms that multiply to 42, but that add to negative 13. So what are the negative factors of 42? negative 42 and negative 1, negative 21 and negative 2. 42 divided by 3 is 14. Do any of those add to 13 yet? 42 divided by 6, 7. Does that one work? Yeah, that one works. So this becomes x minus 7 times x minus 6. Good. Here we have A is 1, B is negative 4, C is negative 21. So we need it to multiply to equal negative 21, and we need it to add to equal negative 4. So since it's a negative 21, we are going to be one positive and one negative factor. So we'll have negative 21 and 1, negative 7 and 3. Yeah. Well, that adds to negative 4, so perfect. X minus 7, x plus 3. Good? So what we had was x plus 7 divided by negative 1 times x minus 6 times x squared minus 13x plus 42 factors 2, x minus 7 times x minus 6, x squared minus 4x minus 21 factors 2, x minus 7 times x plus 3. And now we just multiply straight across. X plus 7 times x minus 7 times x minus 6. Negative 1 times x minus 6 times x minus 7 times x plus 3. So if we hadn't have moved that and divided out the negative 1, we might not have seen that it has a common factor in the numerator. Yeah. And then as well, we have x minus 7 that is common to the numerator and the denominator both. And our final answer after everything has been factored is x plus 7 divided by negative 1 times x plus 3. Don't forget the negative 1, which you could also, if you wanted to, call negative x minus 3. All right, guys, and that is how to simplify, multiply, and divide rational expressions. Good job. Thank you for watching.